Our fourth and last problem from our first categorical logic homework again comes from chapter 4.3 of Hurley's book, section 3 of the practice problems, and number 8 is the problem. Again, we're asked to use Venn diagrams, our effective decision procedure, to determine whether or not a given direct inference is valid or invalid in both Aristotelian and Boolean logic. In this case, our direct inference is the following. It is not the case that some dogs are reptiles as our premise, and our conclusion, some dogs are not reptiles. So again, we're going to use our effective decision procedure. We're going to start by creating a premise diagram, a conclusion diagram, by filling in our premise diagram so that we show what has to be true if the premise is true, the way the world has to be if the premise is true. We fill in our conclusion diagram showing what we need, how the world needs to be in order to make the conclusion true. And we look at our conclusion diagram. Here's what I need. We look at our premise diagram. Here's what making the premise true will give me. If what making the premise true gives me, if how the world has to be, given that my premise is true, is what I need is the stuff that's given in the conclusion diagram, then the argument will be valid in Boolean logic. So we start off in the Boolean logic. We're not going to assume that our classes have any members. Maybe they do, maybe they don't. We'll start off with our premise diagram here. Again, subject class is in the left, predicate class is in the right. We indicate that this is our premise diagram. And our premise is it's not the case that some dogs are reptiles. So we've got a premise that is only going to be true if that standard form categorical statement, some dogs are reptiles, is false. So our premise asserts that standard form categorical statement is false. And so the way we've been doing this, we will create a little diagram here to indicate what would have to be the case for this standard form categorical statement, some dogs are reptiles, to be true. And then we'll use that to figure out how to fill out our premise diagram, which expresses what will have to be the case if that standard form categorical statement is false. That is, the premise itself is true. So some dogs are reptiles. Think to yourself, am I going to shade or put an X in? So this is a particular affirmative statement. It says there's at least one thing, it's a dog, and that thing is also a reptile. So to make that standard form categorical statement in that premise true, there has to be at least one thing. So we're going to put an X in, and that thing has to be both a dog and a reptile because it's a particular affirmative. And so our X goes right there in the intersection. It's in both the dog class and the reptile class. Now that's what it would take to make some dogs are reptiles true. Our premise requires that some dogs are reptiles is false. And so we have to prevent that diagram from being the diagram that describes the world when our premise is true. So if I need an X here in the intersection to make some dogs are reptiles true, to make it the case that some dogs are reptiles is false, I got to make sure that there can't be an X here. And so I shade in that intersection in my premise diagram. And that's the diagram that tells me that it's not the case that some dogs are reptiles. If the world is such that there isn't a thing that is a dog and a reptile, that area is empty, as our shading indicates, then it's not the case that at least one thing is a dog and a reptile, because there can't be any. Now let's go over and look at our conclusion diagram. Our conclusion says some dogs are not reptiles. So again, we want to ask ourselves, do I shade or put an X in? So you might want to stop the video, take a moment, see if you can fill out that conclusion diagram. There's at least one thing here. It's a particular statement. That thing is a dog. It is not a reptile. This is a particular negative statement. There's at least one thing. It's in the dog circle. It is not in the reptile circle. So we're going to need an X in D and only D on that far side of our Venn diagram here. And that's what it would take to make our conclusion true. So now I've got my premise diagram. I've got my conclusion diagram. My conclusion diagram tells me in order for the world to guarantee that my conclusion is true, there has to be at least one thing. It is a dog. It's in the D circle. It is not a reptile. It is outside of the R circle. I need an X right in here. I look over at my premise diagram. If my premise is true, if this is the way the world is because my premise is true, am I guaranteed that I have an X in here? There's nothing indicated in here. So making my premise true doesn't affect this at all. It doesn't determine whether or not there is a dog that's not a reptile. It only requires that there isn't a dog that is a reptile, that this area is empty. So nothing about making my premise true guarantees my conclusion is true. And if that's the case, it violates my definition of validity. And therefore, the argument is invalid in Boolean logic. Now I'm going to have to go back and check to see if the argument is valid in Aristotelian logic. Remember, because I'm clever and lazy, like a good logician, I don't worry about my conclusion diagram. I only worry about my premise diagram. I don't worry about my predicate class in my premise diagram. I only worry about my subject class. So when I'm evaluating an argument for Aristotelian validity, I only look at the premise diagram. I only look at the subject class for these direct inferences, and I check to see if that subject class has at least one member. Is there an X somewhere in there? When I look at this premise, our D circle doesn't have any members. So I know that when I modify the diagram for Aristotelian validity, my premise diagram has to have an X in that D circle. It can't be in the intersection. That has to be empty to make my premise true. And therefore, I know that that X has to go in that D and only D area, area 1. I put that X in. I circle it to remind myself I'm only entitled to that because I'm making that Aristotelian assumption about this argument and its classes. Now, I've got my diagrams for Aristotelian validity. My conclusion says, in order to guarantee that this conclusion, this statement, some dogs are not reptiles, is true, there has to be at least one thing. Call it X. It's in my D circle. It is not in my R circle. Now I look over here at my premise diagram. Under the Aristotelian assumption, this is how the world has to be at minimum in order for my premise to be true. The intersection between D and R, that has to be empty. There has to be a member in my D class. It's got to go here in my D and only D. And so now, making my premise true gives me an X in the area that I need in order to guarantee that my conclusion is true. So this argument is formally valid in Aristotelian logic. But I'm not going to write valid in Aristotelian logic yet, because now I have to go through and decide, is this a good Aristotelian class? So I look at my subject class. My subject class is D. That's the class of dogs. They're definitely dogs, and so it's a good Aristotelian class. So it's formally valid in Aristotelian logic, and it satisfies the Aristotelian assumption there really is a member of that class, the class of dogs, and therefore I write valid in Aristotelian logic.